NAT can be configured. Dynamic NAT is Dynamic Native Address Translation, and it is the type of NAT in which a set of private addresses are mapped or translated to a pool of public addresses that are specified. So here let's consider this topology. Here we have got 6 PCs that are present in this plan, and here we have a serial network, we have another network which contains the server. So here our task is to configure NAT in this router R1 so that the set of IP addresses that are present in this network will be mapped to this range of public addresses when it is sent to the outside world, when it is known in the outside world. So let's first do the basic configurations that are required. The basic things are the IP configurations for all the devices and the IGP interior gateway routing as it is required. So let's go to the PC, let's go to the desktop tab and go to IP configuration. Here we can configure the IP address and mask and the default gateway. So similarly all the PCs and the server is also configured. The IP address. Now for the router, we go to the router and then we go to CLI tab, then we give the command enable to go to privileged execution mode. From here if you give the command configure terminal, we can go to the global configuration mode. Now let's give the command show running configuration so that all the configurations that are already made are displayed. Now here we can see that IP address has been given to this interface FA00 of the router R1 by using the command after going into the interface FA00, the command IP address, the IP address for the interface followed by the subnet mask of the network is given. So in the similar way IP address is given for the other interface as well as the other routers, both the interfaces. So after configuring the IP addresses, we see that this router knows this LAN as well as the serial network, but it does not know this network. So we need to configure static manual routing so that this router knows this network as well. And similarly, the router R2 knows the serial network and this network, but it does not know this LAN. So we need to configure static routing so that R2 knows this network, or any packet that comes to R2 will be so that it should be able to go to this network, and any packet that comes to this R1 for this destination should be able to reach here. So let's configure a simple default static route by saying IP route and then the destination is 4 zeros and then the subnet mask is 4 zeros, then the exit interface is serial 0 and 0, so that any packet which comes to R1 and when R1 doesn't know the route to that particular destination, it will be forwarded to this route. And then in this router, let's say let's again configure default static route. If we see the running configuration, we can see that it's been configured like this: IP route and then the destination network address, the destination subnet mask, and then the exit interface serial 0 and 0. So we have configured static routing. So now the routing is enabled for both the routers so that both the routers know all the networks present in the topology. So now let's configure the NAT. So let's go to router R1. Here we need to first specify the set of IP addresses present in the LAN, or the set of private IP addresses which are supposed to be translated, that is supposed to be given in an access list. So we are going to configure an access simple standard access control list by saying access list and the ACL number, and then by saying permit. Since the traffic has to be permitted through the router, you are saying permit, and then we say the network address of the network which is supposed to be permitted, and then we say the subnet mask. So here we have considered /24 network, so we have given this wildcard mask. It's not subnet mask, it's wildcard mask. So after configuring this ACL, we need to tell the set of public addresses that are supposed to be used for translation. So that we can say by saying this command IP NAT, and then by giving the keyword pool. Here we give the name of the pool, say pool 1, and then here we need to give the range of IP addresses. The starting range is given over here, which is 50.0.0.1, and then the ending range is given next, 50.0.0.5. So we are specifying 5 IP addresses, 5 public IP addresses to be in the pool. And then we can give the keyword net mask, and then we give the subnet mask for this network. So we have considered a default class A network, so the prefix is 8 and the subnet mask is this. So you configured both the set of private addresses as well as the set of public addresses. Now we need to map them both. So for that we give the command IP NAT inside source, and earlier for static routing we gave the keyword as static. Now here for dynamic routing, for dynamic NAT we give the keyword list, and then we say the list number which is associated with the private list of private addresses, and then we say give the keyword pool, and then we say the pool name to which the public addresses range is configured. So we have mapped both the lists using this command. So you configured dynamic NAT, but we are yet to tell the router which interface is connected to the inside part and which interface is connected to the outside part. Now since this is the inside part where the set of private addresses are given, we need to configure this interface of the router saying it is IP NAT inside. So here we can see for the interface FA00 it's configured as IP NAT inside. Similarly for the other interface we need to say for serial 010 of this router we should say IP NAT outside, so that the router knows that this is the outside part where the public addresses are to be known, so that it can do proper translation. Now you configure this dynamic NAT. Let's see how it works. Before that, let's look at a few configurations, few troubleshooting commands. Let's say show IP route. Now we can see the directly connected ones as well as the one which was specified with the default static route, and similarly here also we can see for show IP route two directly connected ones, and then the other one which was specified with the other default static default route. So we had specified this exit interface. So let's go back here and let's say show IP NAT statistics. So till now totally there are 5 addresses. It gives the details which we have configured, and it says 0 hits, 0 misses, 0 expired translations. Most of it is 0 because we are yet to send a packet from one device to the other, so everything is 0. Let's come back to this same command after sending a few packets. Let's check the command show IP NAT translations. Now here this is empty as well because a dynamic NAT works only after we send a packet. So only when we send a packet it's going to pick one IP address from this pool and it's going to assign it or map it to that particular private address of the packet. So it is still empty. Let's send a few packets and then check the commands, and meanwhile let's just enable the debug IP NAT so that we can see the translations that are made. So IP NAT debugging is on. Now let's go to one of the PCs, say PC0, and let's try to ping the server. Let's say ping 20.0.0.2. Now if while it is still pinging, we can take the router R1 and we can see that there are a few things that are listed. We can see that the source is 192.168.0.2, which is the IP address of this PC, and it's been mapped with this IP address. So when the packet was sent, this router which behaves as a NAT device, it picks one of the addresses from this range. Say the first address was picked for this, so that was picked and the destination is this server. So for the next time the source is the same, and since already a public address was assigned, the same is being used and it was sent the second time. Now here it says the source is this, which means the reply packet was coming. So the source is the server, the reply is coming from here, and the destination is 50.0.0.1. The public address is known outside and not the private address. So when this public address, when this packet comes to the router R1, again it's been mapped back to the old one. So it's been mapped back as 192.168.0.2. So again we see that the third packet was sent, and then a reply was got for the second packet, and then again the fourth packet was sent. We got the reply for the third packet, and we see that it's expired. So the pool of addresses was given to this particular PC temporarily, and after a particular number of seconds it expires, which means it takes back the address, public address, which was mapped to that particular private address. Now let's see the result. Here we were pinging, yes, one was timed out, and for the other three we have got the replies. So now let's also check the other commands that we have given. Say show IP NAT statistics. So here we see that there are 3 hits and 4 misses, 4 expired translations, and we see the details because one packet was sent and there were 3 hits, which means 3 times we were able to get the reply properly. So similarly various details are displayed over here, and again if we check the command show IP NAT translations, we see nothing because it has actually expired. So again let's try from another PC. Let's say ping 20.0.0.1 and let's go to this. Let's say show IP NAT translations, and here we'll be able to see this. We're able to see that the inside global the global address, which is the public address, was given as 50.0.0.1, and the inside local, which is the private address 192.168.0.3. So since any ICMP request will by default have 4 messages sent, we have got 4, and here the outside global and outside local are the ones for the server. Now this is for the sender side. So here the global is this and the local is this. So we see the translations, and again if we see show IP NAT statistics, we will be able to see that 1 has been allocated and total addresses are 5. So in a few seconds if we check the same command, we will see 0 because it would have got expired by then. So similarly we also see the total number of hits. Now this is not just for the packet which was sent from PC1 but all together. So the entire statistics is shown here. Now again this address which was assigned to PC1 is getting expired. So if we say no debug IP NAT, these details about the NAT will be stopped. So the debugging is off. Now after this let's check how where the translation is actually happening. Let's say for example from PC2 to server we need to ping. It is successful, of course. Let's go to the simulation mode. Now let's say forward. Now this request, let's again forward it. Now this request has got the source as 192.168.0.4, which is this PC's IP address, and the destination is the server's IP address, which is 20.0.0.2. Now even layers, which means when the packet comes into this router, this is the status. When the packet goes out of this router, let's see what is happening. We see that the source is changed from 192.168.0.4 to 50.0.0.1. Now this IP address is one of the public IP addresses that was specified in this pool. So the private IP address has been mapped to one of the addresses specified in the pools, which is a public address. So the destination remains the same. So the translation happens from private to public when the packet comes like this way. So let's forward it. Here again we are going to get the response. So when it comes back here, we can clearly see that the destination from here would have been, when the packet comes in, the destination was I'm sorry, when the packet comes in, the destination was 50.0.0.1 public address, the source was the server, So the server is sending the response. So source is server and the destination is 50.0.0.1, which is the public IP address. Now the server does not know the private address, it knows only the public address, so it sends the response to the destination with the public address. But when the same packet comes to this router R1, when the packet comes in, the destination is displayed as this public address, but when the packet goes out through this interface, we can see that again network address translation happens, and it is mapped back to its original private address which was assigned to this PC. So the source is the same, but the destination has changed. So this has happened because of network address translation that we have configured. So we are able to successfully configure a dynamic